We're going to focus on different types of mixtures. After looking at pure substances, gases, liquids, solids, we come to realize that it's rare for us to encounter these pure materials. And if we're going to look at mixtures, they have different properties, quite often from the components that they're made of. A good example is steel, which is a mixture of different metals, but it has different properties. Well, if we're going to look at three types of mixtures, I'm going to categorize them based on particle size. And the first thing that we want to look at is large particles. Now, if you have large particles, this means large enough for you to see them with your eye, then these are relatively large, and they can either settle out due to gravity, but how fast they settle out, the rate of settling, is going to vary. So if you wanted to separate the different components of a suspension, the easiest thing to do would be to either use filtration. You can use filter paper. You can let dissolved substances go through the filter paper, but particles that are of a certain size would be trapped by the filter paper. And you can buy different qualities of filter paper that will allow particles of different size to pass through or to be trapped. Another way of separating components of a suspension is going to be with centrifugation. And here you are going to simply spin the particles in order to accelerate the effects of gravity. If we have medium-sized particles, these are called colloids. And when you look at a colloid, they are split into what is called the dispersed phase and the dispersing medium. The dispersed phase is what is dispersed. The dispersing medium is going to be what it's dispersed in. I'm going to shift pages here. And I want you to look at these categories of colloids. Now, first look and you'll see along the left-hand margin that we have our different phases: gases, liquids, and solids, which could be in the dispersed phase. And then we have the gas, the liquid, or the solid, which could be our dispersing medium. So let's look at some examples. And what you want to focus on here is terminology. Do you understand what these terms mean? So let's say that you have a gas that is going to be suspended, as you can see, either in a liquid or a solid. Well, this would be called a foam. An example of a gas in a liquid could be something like whipped cream or shaving cream. You know, if you have shaving cream coming out of a can, as soon as it comes out of the can, it kind of expands as air is put into the liquid. Same thing happens if you have a gas in a solid. And this could be something like a sponge or styrofoam. Now, if you think about styrofoam coolers, you know you can go to the store and get one for almost nothing. And then there are some that you pay quite a bit for. Well, the difference in price is going to depend on how much air is dispersed into the solid. If you have a lot of air, the cooler is pretty cheap. It's going to break easily. If you have more controlled mixing of the phases and less air, then you're going to have a better cooler that's going to help me keep the dry ice around longer. Okay, so those are examples that you would want to think of here. And these are all examples of foams. That's the key word, foam. All right, Let's look at the next example of a dispersing phase in a dispersing medium. And here we're going to look at liquids and gases. Liquids and gases. This is called an aerosol. And fog or mist is where we have water vapor dispersed in the air. These particles are not large particles, but like all colloids, these particles are going to be medium in size. And so we can still see the water vapor in the fog or in the mist. So we know that we have these particles dispersed in the air. Aerosols are another good example, or even clouds. Now, if we have a liquid dispersed in another liquid, that's what we call, liquid in a liquid, an emulsion. And a very good example of an emulsion would be milk, mayonnaise, or salad dressings. Years back, if you bought salad dressing, you would have to be sure that you shook it up really well to make sure that it was well mixed. But not today. And the same thing, for the same reason with mayonnaise and milk. You know, if you were to look at milk, milk is mainly water. Mainly water. But there is some fat in milk, and you know that. You know there's fat there because you can get whole milk, 2% milk, 1% milk, or skim milk. Now, I made the mistake of thinking that if I had 2% milk, that 98% of the fat was removed, and all I had to drink was the 2% that was left. Well, it turns out that whole milk is only about 4% fat, so I wasn't getting as much of an advantage as I thought I was by drinking 2% or 1%. Right now I'm down to skim milk. And there's something that we need to think about. When we're looking at milk, quite often what we have is the milk separating. Have you ever opened a carton of milk and found curdles clumped at the top? Not very appetizing, is it? So what's causing the curdling of the milk, the fat to separate away from the water? A better question right now might be, what keeps the fat dispersed in the water, since they are not alike? And so there is something in milk that you know about. It's called casein. And it's the casein that prevents the fat and the water from separating. And casein is called an emulsifying agent. What about mayonnaise? Mayonnaise is oil and water. I make fresh mayonnaise at home. I learned how to do it when I was in Spain, and it is delicious. Well, what keeps the oil and the water in one phase and prevents them from separating? It's an egg yolk. That's the emulsifying agent in mayonnaise. Okay, well, we'll look at one more keyword here for colloids and move on. And this is where we're going to have a solid dispersed in a gas. This is called a solid aerosol. And look at the examples here. Smoke, airborne viruses, and I guess if you've ever sat behind a big school bus and watched it pull out from a parking lot, you can see that big black puff of smoke coming out of the tailpipe as those solids get dispersed in the air. Solid aerosols. So these are just some examples of our colloids. Medium-sized particles. We call them the dispersed phase and the dispersing medium. What's different between this and a suspension? Well, here, the particles can pass through filter paper quite often. And there's something that's very interesting about colloids. You need to know the term Brownian motion. Sometimes when you go swimming in a lake and you open your eyes underwater, you may see all these particles suspended in the lake water. They're not settling to the bottom. They're not big enough to settle to the bottom. And yet they stay up in the water. What happens here is that these particles are involved with collisions with the surrounding water, and the water bouncing on the particles keeps them in suspension. So, you know these different types of solutions that you see here, and we're going to talk about how you would identify a colloid. So, if we wanted to identify a colloid versus a true solution, what you'd want to do is pass light through your sample. So let's say that you have a bottle, and in this bottle you have a suspension of medium-sized particles. You can see them just like you can see fog. Now in another bottle, you have a true solution. We haven't talked about solutions yet, but the solutions have particles that are so small you cannot see them. All right, let's take a flashlight beam. A beam of light. Here's our flashlight. Little switch here, and we're going to turn on our beam of light. Now, as the beam of light comes into a true solution, the particles are so small that the beam of light will pass straight through without being distorted, reflected, refracted. If this beam of light continues though, and it goes into a colloidal suspension, this beam of light is going to be redirected based on how it hits the particles. Now, this is called the Tyndall effect. Tyndall. Tyndall effect. All of this is in your textbook. You can read about it. Okay? The Tyndall effect. This is where particles are large enough to scatter light. And so this is the way you would tell the difference between a solution and a colloidal suspension. If the particles are large enough, they can split the light. Okay, I'm running out of time here, so I'm going to stop with looking at the colloids, but we've examined colloids and suspensions here. Suspensions where the particles are very large, they're going to settle out simply due to gravity, and of course you can speed it up if you use a centrifuge to do this. Then you have your colloids, lots of terms here that we've run through, the Tyndall effect, but also the difference in a foam, an aerosol, an emulsion, the emulsifying agent, and solid aerosols. What is the dispersing phase? What is the dispersing medium? And good examples we've talked about, things that you encounter in your everyday life. So read a little bit more in your textbook, and we'll move on to true solutions. Solutions where the particles are very small. Small enough so that you can't see them, small enough so that you have a homogeneous mixture. If your solution is well stirred, you can not tell any difference in your solute and your solvent. Particles are not going to fall out upon standing. The solution's going to look clear, and a beam of light is going to pass right through it. Your solution's also going to pass through filter paper. It's like we consider it to be a single phase, even though there are two components to every solution: the solute, what is dissolved, and the solvent, what it's dissolved in.